Good evening, Precal students. I'm sure you are wondering why I have gathered you here on this fine evening to talk pre-calculus. Well, today we shall be proofing, and proofing some more. We are going to be working with our trig proofs today. Proofs! Oh my! Dirty little word from geometry there, proofs. Let me say this. When I say the word proof, a lot of people associate proof with the things in geometry that you did where, like, prove a triangle is a right triangle and you had to use, like, side, or angle, blah, 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 whatever. And you had to use a lot of theorems and a lot of postulates, and you had to actually go out and you had to prove stuff. You had to say this is this and this is the reason why. Well, trig proofs are more based on algebra. It's kind of like show that one thing equals another, and just show it with algebra. So it's not really something to be feared or concerned about. But to get on the subject of proofs, you remember the notes from yesterday? I got them here handy. The basic 8 trig identities, right? You got your box of the basic 8s. And then a couple of those Pythagorean identities from that other page over there. You'll need those. And what we're going to do is I'm going to put those over here to the side. And what we're going to do is use those to simplify as much as possible. And to prove that two things are equal. So I want you to pause the video for a second and get those out if you don't have them. Pause. Okay, so before we get into the proofs are going to happen down here. 1 through 6 on the front page of your notes is just a few tips and tricks on the algebra portion of it. For example, it says multiply and simplify as much as possible. So we've got tangent theta plus 1 squared. Okay, well, you know that tangent theta plus 1 squared is not tangent squared plus 1 squared. We know we don't just take that square and put it everywhere that we got. And instead, what we're going to do is we are going to take tangent theta plus 1 and multiply it by itself. That's what a square is, right? So this is actually tan theta plus 1 and tan theta plus 1. All right, multiply that out. You get tangent times tangent is tangent squared theta. Tangent times 1 is tangent. Tangent times 1 is tangent. So I've got tangent plus tangent, which is plus 2 tangent theta. And then 1 times 1 is 1. Okay? So I've got tangent squared theta plus 2 tangent theta plus 1. And I'm supposed to be simplifying this thing as much as possible. Okay, so what I'm going to do is I'm going to look at what I'm given, and I'm going to go back to my notes from 3-1, and I'm going to see, does anything here match up anything that I've got on those other notes? For example, I know that over here, I'm looking for a tangent squared, a 2 tangent, or a 1. Well, if you look at your basic 8, isn't 1 plus tangent squared secant squared theta? Just because addition is commutative means we can move stuff around and it's still the same. Kind of like 2 plus 3 is the same thing as 3 plus 2. Couldn't we say that tangent squared theta plus 1 is secant squared? So what I'm going to do is take this guy, and I'm going to call that secant squared theta plus 2 tangent theta. That'll give you an idea of where we're headed. I'm trying to simplify as much as possible. Okay, number 2. This is actually, if you remember, this is actually a plus b, a minus b. Secant theta plus tangent theta times secant theta minus tangent theta. A plus b times a minus b is equal to a squared minus b squared. It's called the difference of two squares formula. If you ever forget that, just multiply it. Secant times secant is secant squared. Secant negative tangent is negative secant tangent. Secant positive tangent is secant positive tangent. So those two would cancel out. That's why there's no middle term here. And then tangent times negative tangent is negative tangent squared. So this is going to be secant squared theta minus tangent squared theta. And I'll be, if secant squared theta minus tangent squared theta in 1, well, goodness, I'll be darned. Okay? And then for 3 through 6, it's factoring. Now 3 is actually the opposite of 2. 2, we were taking a difference of two squares and ending up with that, right? A plus b, a minus b. Here, we're starting with the difference of two squares. A squared minus b squared. We need to go to this. So that's going to be sine plus cosine times sine minus cosine. So this is factoring the difference of two squares. Sine theta plus cosine theta times sine theta minus cosine theta. Factoring! Yay! Okay, on number 4, I want to kind of reword this, because when we get to factoring trig functions, a lot of people kind of go haywire on it. For number 4 rather, cosine squared theta minus 2 cosine theta plus 1. If cosine theta was x, wouldn't this just be x squared minus 2x plus 1? So factor it just like it's that. You know it's going to be, what is that here? We got x minus 1 minus 1. Right? So now let's do that over here. So this will be cosine of theta minus 1 times cosine of theta minus 1. Okay, and that is completely factored. Now there is one way you could simplify this down if you wanted to and get it to one set of parentheses. Since we are multiplying the same thing by itself, cosine theta minus 1 squared. Okay, and that's factoring. So this is the difference of two squares. This is straight out factoring. This is going to be a greatest common factor, because tangent theta plus sine theta tangent theta, that doesn't factor out with first times first, with it being able to FOIL it. It doesn't factor out that way. So what we would look for then is a GCF, greatest common factor. In other words, I've got tangent theta and sine theta tangent theta. Well, what do they have in common? They both have a tangent theta. So let's pull a tangent theta out. And what's left? If I divide tangent theta by tangent theta, what do you have? You got a 1 plus sine theta tangent theta divided by tangent theta, you got sine theta. Not too shabby, is it? So we had difference of two squares, straight out factoring, greatest common factor, and then number 6. 1 minus sine to the 4th? Holy smoke. What if I said that that was the difference of two squares? In other words, 1 to the 4th power is 1, right? Sine to the 4th power obviously is the 4th power as well. Well, if I wanted to factor this using the thing up top, a squared minus b squared, that would kind of just be saying that that was squared itself, right? I know you kind of hardly see that. That's kind of the point. But imagine this. 1 minus sine to the 4th. Wouldn't I get that if I had 1 minus sine squared theta, a minus b times a plus b, 1 plus sine squared theta? It's kind of like saying this is 1 to the 4th, right? It's 1 to the 4th power. So split it up. 1 squared is 1 to the 4th, which is all just 1, so that makes it easier. Sine squared times sine squared is sine to the 4th. This is a difference of 2 squares. It's just a power of 4 now. Nothing wrong with that. Okay. I want to do something really quickly here. Let's go ahead and factor this again. This first one here is again a difference of 2 squares. We have 1 minus sine theta and 1 plus sine theta. What about this guy over here? This 1 plus sine squared theta. Is this a difference of 2 squares? No, there's a plus sign in there. So will this one factor? Absolutely not. Sine squared theta. So if it's not a difference, if it's a plus sign, that will not factor. Then there is a reason for that. If you imagine it this way, x squared plus 1, to factor it, we should be able to set these factors equal to 0 and then solve for theta if we wanted to. But if I set this guy equal to 0, minus 1, x squared equals negative 1, and you go to take the square root of that, uh-oh. Major no-no on the square root of a negative. So this does not factor. Same thing here. Does not factor because it's a plus sign. Okay, now, a couple of things about this. This guy right here, some of you may have noticed that it's also an identity, right? Also an identity. But it was saying to factor, so I went ahead and factored it. The directions said to factor, so I'm going to factor it. Up here, if I wanted to simplify it as much as possible, this 1 minus sine squared, come over here, 1 minus sine squared could have been just cosine squared theta if I wanted it to. But I'm not simplifying, I'm just factoring. All right, number 7. Use the basic 8 identities to simplify the left side to equal the right side. Read how the question is actually worded. It says to simplify the left to equal the right. I'm going to avoid touching the right side unless I absolutely have to do it at the very end. Okay, I'm going to work with the left side. I'm only going to work on one side to prove that something is true. For me to prove that this is this, I shouldn't have to touch this side. Okay, simplify the left side to equal the right. Now you won't always start with the left. Sometimes you may start with the right. There's a rule for that I'll get to a little bit later. But I want you to write something down for me. Work only one side to prove an identity is true. Wow. I am going to work with only one side to prove an identity is true. Meaning I'm not going to touch secant x, not yet. Okay, so tan x over sine x equals secant x. Okay, so a couple of things here. We've got tangent x, we've got sine x. Well, which one of those have something we could plug into it? Going back to my basic 8 here. I know that tangent x is sine over cosine, right? Let's use that. So wouldn't this be sine x over cosine x all over sine x equals secant x? Makes sense, right? Now I do not like how I've got fractions and top of fractions and all that stuff.